Hey there. Today we're going to be talking about the 9 times table and a trick that you can use to help you not only memorize it but understand it and why it is the way it is. But today we're only focusing on multiplying 9 by a single digit number. Once again, multiplying 9 by only a single digit number, okay? Now, here's a problem I have that I wrote. This only works with 9s now. It's got to be a 9 in there somewhere. Single digit number multiplying it by. Now, the most common trick that people like to use is the finger trick. Once again, here's the problem. Now, in reality, if I were doing this, first of all, I'd have my 10 fingers up like this. Now, in reality, I'd be looking at it this way. But because you're looking at me, on the screen like this, I'm going to make this left, this is right, your left, your right. And of course, in your mind, these fingers would be numbered. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Okay. Now, once again, it's 9 times 4. You would bring down the fourth finger, which for you would be this one, to get your answer. You would look at the number of fingers that you have to the left of the down finger, in this case 3, and then you'd look at how many fingers you had up to the right of the down finger, and we get this one, which in this case is 6. 3, 6. So the answer would be 36, right? Okay. Yeah, it works, but you know what? I want to get to the point where I don't have to put my paper down, or in this case, put this down, put my pencil or marker down to figure it out. I want to make this as easy as possible. Think about it, write it down. Because at some point, not that I discourage using the finger trick, but I do want you to kind of get more mental with it, because the more mental you are with memorizing your times tables or knowing how to do them, the easier it's going to be with everything you do in math that involves multiplying. That's fractions, patterns, whatever it is, okay? So here's what I'm going to do. Excuse me. I'm going to do the same problem, but in a different way, the way I want to show you. Here it is, right? Now, I'm going to take the number that is not 9, which in this case is 4. I'm going to take 1 away from that 4. What's 4 minus 1? 3. Now I do a little more mental math and I say, what do I add to 3 to get 9? Because remember, it's got to be a 9 there somewhere. There's got to be a 9. 3 plus what is 9? 6. And what do you know? That's the same thing I got without doing all this, right? Ooh. Okay? There it is. I'm going to give you another one to show you that it works. Remember, feel free to pause, rewind, replay, whatever it is. Here's the other one. Do the same thing. What am I doing first? Taking the number that's not 9, taking 1 away. What's 7 minus 1? 6. What do you add to 6 to get 9? What do you know? 3. Reverse of the last one. But once again, 6 plus 3 is 9. There it is. Now I know what you're thinking. You're thinking, wait a minute. All you've been showing me are 9s being multiplied by a number that's not 9. What if you're multiplying 9 times 9 itself? Doesn't really matter. Still a single digit number, right? Pick a 9, any 9. Take 1 away. What do you add to this to get that? Or that, in this case. There it is. Same rules apply. Remember, 9 times a single digit number. Now, I'm going to show you why this works. I'm not just here to show you the trick. I want to show you why it works. Just bear with me a second. I should be able to get it all on here. I'm going to go up to here, actually. All right. This is the 9 times table factors from 9 times 1 to 9 times 9, which we did before, right? Now watch what I do. Notice all these numbers are double digit. This one isn't, right? In a way it is. It's got to put a 0 here. Remember, we may in real life or in regular life write a 9 just by itself, but there is a 0 there that shows that there are no 10s. It's just no 10s or 0 10s and 9 1s. For this case, I'm using 0 as the placeholder. Like I said before, 0 is the placeholder when you need it. Now watch what I do. See if this looks familiar. Try to do this neatly as possible. Notice what I did. The good old T-bar. Straight down. This T stands for what? Place value, 10s. This O stands for what? 1s. Here are my 10s digits. Here are my 1s digits. Notice what's happening. First of all, the pattern is that as the 10s digits grow larger, the 1s digits get smaller. This is regular counting 0, 1, 2, 3, 4, 5, all the way down. This is regular counting backwards. 9, 8, 7, 6, 5, 4, 3, 2, blah, 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 right? See what I'm saying? Another pattern to the 9s. Also, one more thing I want to share. Look. 0 plus 9, 9. 1 plus 8, 9. 2 plus 7, 9. 3 plus 6, 9. 4 plus 5, 9. Of course, 5 plus 4, 9. All the way down, yes. I said it before. They all have digits that add up to 9. Coincidence? I think not. Because even when you're doing the finger trick, you start with 10, you take 1 away, you're always winding up with 9. No matter what. Okay? That's how it is. That's why it works. I'm going to give you one more, but I'm going to have you do this one while I do it secretly, and then we'll compare. Okay? We'll share answers. Here it is. Do that one, and I'll do it too, using the method that I showed you. Okay? Here we go. Okay, ready? Is that what you got? I hope so, because look, here's your 8. You take away 1, 7. What do you add to 7 to get 9? 2. 7 plus 2 is 9. And if you go back to the part where I showed you the T chart there with the 10s and 1s, you'll see that that is the case. Okay? So once again, the number that's not 9, or could be 9, as long as it's single digit, take 1 away. What do you add to that number to get 9? That's your 1s digit, and you got it. Okay? Keep replaying, keep practicing, get used to it. Make sure it's always a 9 with a single digit number. And before you know it, you'll realize that you'll never have to use your fingers again. All right? Hope that helps you.